Good morning, students. Exercise 9.8, problem number 5. Find the area of the region bounded between the curves y is equal to sin x and y is equal to cos x and the lines x equal to 0 and x is equal to pi. So here two curves are given. We are going to find the area bounded between two curves. So the first step, you have to find the point of intersection. So you have to solve these two equations. So here in the place of y, you are going to substitute sin x. So sin x is equal to cos x. Sin and cos value will be same when x is equal to pi by 4, that is 45 degree. So 45 degree belongs to the interval 0 to pi because our limits varies from x equal to 0 to x equal to pi. So therefore the 45 degree belongs to the closed interval 0 comma pi. So after finding the point of intersection, you have to go to draw the diagram. Okay, so now we are going to draw the diagram. So x-axis, y-axis has to be drawn. So first you have to draw the curve y is equal to sin x. You see that? So x-axis and y-axis. So we have to make a tabular column for sin x. Here x, the curve is y is equal to sin x. Put x is equal to 0. Sin 0 is 0. And x is equal to pi by 2. So x equal to pi by 2 means 90 degree. Sin 90 degree is 1. And next x is equal to pi. Sin pi is 0. So the point here you have to mark on the x-axis 0. Here you will have pi by 4 because the point of intersection is at pi by 4. Next you have to go to pi by 2. Next pi. Okay, the first point is 0 comma 0. So it will be here. Next pi by 2 comma 1. So you mark here as 1. So this is pi by 2 comma 1, this point. And next one pi comma 0. So you see that using these 3 points, the sine curve between 0 and pi is like this. Okay. So here only I have drawn. So using the green color 0 comma 0 and pi by 2 comma 1 and pi comma 0. So I have drawn the y is equal to sin x curve. Next I have to go for y is equal to cos x. So the curve is y is equal to cos x. Y is equal to cos x. So you have to go for the tabular column. So put x is equal to 0. X, if you substitute 0, cos 0 is 1. X equal to pi by 2, 90 degree, cos 90 degree is 0. X equal to pi means cos pi is minus 1. So using the points, we have to draw the cos x curve. So 0 comma 1. So this is 0 comma 1. Sorry, this is minus 1. So 0 comma 1 point is here above y, that is above x-axis. It is on the positive side of y-axis. So 0 comma 1. Next pi by 2 comma 0. This is the point pi by 2 comma 0. Then x is equal to pi. It is minus 1. So here you will have. So the curve, cos x curve in this interval 0 to pi, how it will be? It will come. It will touch the x-axis at pi by 2 comma 0. Then it will come. So here you see that in this diagram, the red color curve is the cos x. So this is your y is equal to cos x. So in the green color curve, y is equal to sin x, and here this is y is equal to cos x. So what is the lines given? X is equal to 0 and x is equal to pi. So x is equal to 0, this is the line, that is y axis, and x is equal to pi. So you have to draw, this is the line, x is equal to pi. So we have to find area between these two curves. So which area will come? So here you will have this part, and pi by 4 you will have only this point and the remaining this area up to pi. Okay, so you have to mark. So this is the area will come. Okay, so this only we have marked area between the two curves, y is equal to sin x and y is equal to cos x. I have shaded here. Okay, you see now first after finishing the diagram, you have to choose the axis. But here you see x-axis. X-axis means you see that here there is a division in the diagram. Here you will have only 1 point. So how this problem is going to be solved means 0 to pi by 4. In this interval you are going to find this area. Then pi by 4 to pi. So in this interval you are going to find this area separately. But you are having two areas. One is from 0 to pi by 4 in this part, and pi by 4 to pi. So this shaded part we are going to find. Okay, so therefore the required area, we are going to choose the x-axis. So the required area is equal to, one is from 0 to pi by 4 plus pi by 4 to pi. Okay, so we have chosen x-axis. So therefore x-axis means what you have to do, you have to draw the line, arbitrary line, which is parallel to y-axis, and it has to touch the, what is that, the curve. So the line touches the first red color curve here, and then green color curve. Okay, so x-axis if it is chosen means the formula is y1 minus y2 into dx. Here also the same way, y1 minus y2 into dx. So first you consider the first area. Okay, we have to choose y from the first curve and the second curve. So here which will be the first curve and which will be the second curve we have to find. So for that you take the diagram and draw the parallel line. You take this is the parallel line parallel to y-axis, and it has to draw towards x-axis, means it touches first red color curve, then green color curve. The red color curve is cos x and the green color curve is sin x. So for this part 0 to pi by 4 up to 0 to pi by 4, so y has to be taken from cos x, that is y1, and next y has to be taken from sin x. So that only I have written. Y1 is y from the curve y is equal to cos x, and y2 is y has to be taken from the curve y is equal to sin x. So integral 0 to pi by 4, first one cos x minus sin x, because y is equal to cos x, y is equal to sin x. So cos x minus sin x. So the integration of cos x is sin x, and the integration of sin x is minus cos x, and the limits varies from 0 to pi by 4. So here minus into minus plus. So apply the upper limit, pi by 4, sin pi by 4 plus cos pi by 4 minus sin 0 plus cos 0. Sin pi by 4, sin 45 degree, that is 1 by root 2, plus cos 45 degrees 1 by root 2, minus sin 0 is 0, cos 0 is 1. So 1 by root 2 plus 1 by root 2 is 2 by root 2 minus 1. So this 2 can be written as root 2 into root 2. 1 root 2 is getting cancelled. So here you are having root 2 minus 1. So the first curve we have completed. So next one we have to take this part. Okay, here this also we have taken the x-axis. So the limits varies from x is equal to pi by 4 to pi. So here we have written pi by 4 to pi. Where we have to choose y. Y is from which curve? You see the same thing. If you draw any arbitrary line parallel to x-axis, first it will touch the green color curve, then into the and red color curve. So therefore y has to be taken from sin x, and then next to y has to be taken from cos x. So here for the second one, that is from pi by 4 to pi, y1. So the y1 is y from the curve y is equal to sin x, and next y2 is y from the curve y is equal to cos x. So therefore y1 is sin x minus cos x. So the integration of sin x is minus cos x. This is cos x integration is sin x. In between you are having minus, so this minus is written. From these two terms, if you take minus out, it will become plus. So pi by 4 to pi. So apply the upper limit, cos pi plus sin pi minus cos pi by 4 plus sin pi by 4. Cos pi is minus 1, sin pi is 0. And cos pi by 4 is 1 by root 2, sin pi by 4 is 1 by root 2. So here this minus is written as it is. Here the first term is minus 1, here minus 2 by root 2. So there is here, if you apply the minus, minus into minus plus 1, minus into minus 2 by root 2 is plus 2 by root 2. If you cancel this, your answer is 1 plus 2 root 2. So what we have to do? We have to add the two areas. So therefore the required area is, what is the first area? It is, your answer is, what is it? It is root 2 minus 1. The second one is, what is it? It is 1 plus root 2. If you add these two, you will get the answer as minus 1 and plus 1 getting cancelled. Root 2 plus root 2 is 2 root 2. Okay, so we'll go to the problem number 6. Find the area of the region bounded by the curve y is equal to tan x and y is equal to cot x, and between the lines x is equal to 0 and x is equal to pi by 2. See now, first you have to find the point of intersection. So you have to solve those two equations. So here y is equal to tan x and y is equal to cot x. So in the place of y, you can substitute tan x. So therefore tan x is equal to cos x, cot x. So tan and cot value, they are same only at pi by 4. This pi by 4 belongs to the closed interval 0 comma pi by 2. So after finding the point of intersection, we have to go to the diagram. You see that? For that, you have to draw x-axis and y-axis. Okay, so you have to draw x-axis and y-axis. So this is x-axis and y-axis is drawn. So this point is 0 comma 0, and your limits varies from x equal to 0 and x is equal to pi by 2. So here I have drawn pi by 2. X value is pi by 2. Okay, so it is both the values are same at x is equal to pi by 4. So pi by 4 is marked here. Okay, you see that tan x, what is the curve? We have to take tan x. So x, here it is y. So y is equal to tan x. Put x is equal to 0. Y also 0. X is equal to pi by 4 means it is 1. So x is equal to pi by 2, it goes to infinity. So you have to draw the vertical line at pi by 2. Vertical line at pi by 2. Okay, so you just mark the points. What is that? 0 comma 0. 0 comma 0 will be here. And pi by 4 it will reach 1. So here you will have 1. Pi by 4 comma 1. Then pi by 2 it goes to infinity. So therefore y is equal to tan x will be like this. And it will touch, it will not touch, it will reach to infinity. So this is your y is equal to tan x. You see the diagram. Here the same way 0 comma 0, pi by 4 comma 1, then it reached to infinity when x is equal to pi by 2. The green color curve is drawn. Y is equal to tan x within the limit 0 to pi by 2. Next we have to draw the curve. What is it? Y is equal to cot x. Y is equal to cot x. See that the tabular column. What is your x? X is 0. Cot 0. What is cot 0? It is 1 by tan 0. So 1 by tan x. Isn't it? Cot x is 1 by tan x. So if we substitute x as 0, tan 0 is 0. 1 by 0. That is infinity. Okay. Next x is equal to pi by 4 if you substitute. That is tan pi by 4 is 1. So 1 by 1 is 1. And next x is equal to pi by 2. Here tan pi by 2 is infinity. 1 by infinity is 0. So see now the curve 0 comma infinity. So when x is 0, the curve is infinity. And pi by 4 it comes to 1. And pi by 2 it is 0. So therefore you have to draw the cot x curve like this. Okay. So they will meet at pi by 4. So now you see the diagram. I have drawn the red color curve representing y is equal to cot x. Okay, you see now here this is the area. We have to area between the two curves from 0 to pi by 2 is this area we have to find. So this area can be written as, so it can be splitted 0 to pi by 4 and pi by 4 to pi. You look at this 0 to pi by 2, you will have what is involved? Only tan x is involved. So the green color curve, so tan x is involved, not two curves. Here when 0 to pi by 4 in this interval, only one curve, that is y is equal to tan x is involved, and pi by 4 to pi by 2 you will have a red color curve, that is y is equal to cot x. So we have to take the area, required area is equal to integral 0 to pi by 4. 0 to pi by 4. We are taking the x-axis. So 0 to pi by 4. So only one curve, that is what? Tan x. So therefore only one curve means if you are using x-axis, integral a to b y dx, that's all. Okay, so y is tan x. So integral 0 to pi by 4 tan x dx. In the next interval, what is pi by 4 to pi by 2? In this you will have red color line. So that is y is equal to cot x. So in the place of y you have to substitute cot x. And the tan x integration is log secant x. And cot x integration is log sin x. And the limits varies from first one 0 to pi by 4 and the second one pi by 4 to pi by 2. If you apply the upper limit log secant pi by 4 minus log secant 0. Next one, next term, if you apply the upper limit log sin pi by 2 minus log sin pi by 4, lower limit. So secant pi by 4. Pi by 4 is 45 degree. Okay, secant pi by 4. That is the reciprocal of cos pi by 4. Cos pi by 4 is 1 by root 2. So the reciprocal is root 2. So log root 2 is the answer for this term. And secant 0. So it is 1 by, what is that? 1 by cos 0. Cos 0 is 1. So 1 by 1 is 1. And sin pi by 2. Sin 90 degree is 1. So therefore it is log 1. And here's log sin pi by 4. Sin 45 degrees 1 by root 2. So it is log 1 by root 2. And see that minus log 1 and plus log 1 getting cancelled. This will become minus log 1 by root 2. So see now this 1 by root 2 can be written as, what is that? You can write this as log of, what is that? It's a here you will have minus log 1 by root 2. So minus log 1 by root 2. So it is minus log of root 2 the whole power minus 1. You can write this. According to the logarithmic function, this minus 1 will come to the front because m log a is equal to log a power m. If you have log a power m, you can write the power in the front m log a. So that's why this minus 1 will become in the front, it will become log of root 2. So therefore minus log 1 by root 2 can be written as plus log root 2. So log root 2 plus log root 2 is 2 log root 2 will be the answer. So we'll come to the next problem. What is problem number 8? Father of a family wishes to divide his square field bounded by x equal to 0, x is equal to 4, y is equal to 4 and y is equal to 0 along the curves y squared is equal to 4x and x squared is equal to 4y into 3 equal parts for his wife, daughter and son. Is it possible to divide? If so, find the area to be divided among them. You see that the square field, it is bounded by one side x equal to 0. X equal to 0 means what is it? It is y-axis. So y-axis is taken as x equal to 0 and x is equal to 4. So here I have drawn the line x is equal to 4. Okay, next y is equal to 4. So you have, this is the line y is equal to 4. Okay. So next one, y is equal to 0. Y is equal to 0 is nothing but the x-axis. So one side x equal to 0 means y-axis. Another side x equal to 4. Next y is equal to 4. This is the line. And y is equal to 0 means x-axis. So you will get a square field. Okay, this is the square field. Okay, this square field is divided into 3 equal parts using along the curves y squared is equal to 4x and x squared is equal to 4y. On seeing the curve y squared is equal to 4x, it's a parabola which is open rightward. So therefore the red color parabola is drawn. This is open rightward, that is y squared is equal to 4x. So the general form of the parabola which is open rightward is y squared is equal to 4ax. Here you are having y squared is equal to 4x. So it is in the standard form. So I have drawn, it is the vertex is 0, 0, 0. I have drawn the parabola which is open rightward using the red color. And you see that x squared is equal to 4y. It's a parabola which is open upward. So using the blue color, I have drawn the parabola which is open upward. Okay, so both the parabolas has to touch in 2 points. These 2 points you have to find. So you know very well this point is 0, 0. So we have to find here. I have marked 4, 4. But first you have to find the point of intersection of these two curves. You see that we are going to find the point of intersection of y squared is equal to 4x and x squared is equal to 4y. We have to solve those two equations. So from this, from the first curve, you can write x is equal to y squared by 4. That has to be substituted in the second curve. In the place of x as y squared by 4, the whole squared is equal to 4y. So it is y power 4 by 4 squared is 16. 16 into 4 is 64. You bring this term to the left side as minus 64. From these two terms, y is common. If you take it out, it is y cube minus 64 is equal to 0. So when this y is equal to 0, so y you are getting y is equal to 0. So when you solve, 64 can be written as 4 cube. It is in the form of a cube minus b cube. So you can use the formula a minus b. So a minus b means y minus 4 is equal to 0, y is equal to 4. The remaining two roots are imaginary, so we will not take it. So you are getting y is equal to 0 and y is equal to 4. When you substitute y is equal to 0 here in this curve, 0 by 4 is 0. So x is also 0. And y is equal to 4, if we substitute, it is 4 squared by 4. 4 squared, so 1 4 is getting cancelled, you are having 4. The point of intersection is 0, 0 and what is it? 4, 4. So that's why in this diagram, I have marked the point of intersection of the two curves is 0, 0, this point. The next one is 4, 4. Here x-axis 4 units and y-axis 4 units. This point is 4, 4. So both the curve touches. So here this square field is divided into 3 equal parts. So one is A1, that I have marked the area in yellow color. Okay, next one A2. This A2 is the area between these two curves. And A3 I have marked in green color. So first it is possible to divide. So we have divided along the curves. If it's so, what is the area we have to find? So first we are going to consider, we are going to find the area 1. You see that this area is, this A1 is bounded by the curve. Which curve? The red color curve. Okay, so what is the red color curve? Y squared is equal to 4x. In A1, which curve is not involved? The blue color line is not involved, only red color line. So you have to choose which axis. X-axis if you choose, see that x-axis means here you are having x-axis. So see that x equal to 0. This is the line x equal to 0. X is equal to 4. So which variable will come? See now the red color line, x-axis, okay, x equal to 0 to x equal to 4. Now this the blue color as well as the green color part will come. But A1 is what? Only the yellow color part. So here for finding the area, we are not going to choose the x-axis. We are going to choose the y-axis. You see now, area bounded by the red color line, y-axis, y is equal to 0 to y is equal to 4. So y is equal to 0 means the whole line, but area bounded by this the curve will come, only you will get the yellow color part. So see that area bounded by the red color curve, that is y squared is equal to 4x, y-axis, y is equal to 0 to y is equal to 4. So you will get the yellow color part. So for finding the area of A1, that is A1, you are going to choose the which axis? Y axis. How many curves are involved? Only one curve. So therefore the formula for A1 is equal to integral. The limits varies from, what is it? It is 0 to another y is equal to 4. So 0 to 4. And you are choosing the y axis. So this area is, how it is? It is right of y axis. So it will be positive. So therefore it is x dy. So x has to be taken from the red color line. Which is your red color line? Y squared is equal to 4x. From that you have to choose x. So x is what? Y squared by 4. So here in the place of x I have substituted y squared by 4. This 4 is a constant. So it is taken out. So here y squared. So if you integrate y squared, it is y cubed by 3. This 3 also is taken out. So 1 by 12. If you apply the upper limit, 4 cube minus lower limit is 0. What is 4 cube? Is 64. 64 by 12. If you cancel with 4, it is 16 by 3. So the area bounded by the red color parabola y-axis, y is equal to 0 to y is equal to 4 is 16 by 3. So next one we are going to find A2. Okay, A2 is nothing but, you see the diagram, A2 is a purple color I have marked. It's a area between the two curves. So we have to follow the procedure of how to find the area between two curves. So first you have to find the point of intersection. So we have found it. Next we have drawn the diagram also. The third one you have to choose the axis. So here see, here you can choose x-axis as well as y-axis, because x-axis means x equal to 0 to x equal to 4. So we can choose x-axis as well as y-axis. So here in this problem I have chosen y-axis. So see that y-axis is chosen means, you have to use the formula x1 minus x2 into dy. So you can choose x-axis also. If you choose x-axis, you have to write the formula y1 minus y2 into dx. Here I have chosen the y-axis. So I use the formula integral x1 minus x2 into dy. Okay, what is the limit for A2? So see that this curve, here it starts, it ends with 4, 4. You are choosing the y-axis. So this is, y value is what here? Y is equal to 0. This is the line. And here y is equal to 4. So there is no change in the limit. 0 to 4, x1 minus x2 into dy. What is x1? X has to be chosen from the first curve. And the x2 means x has to be chosen from the second curve. You see that you have chosen y-axis. Y-axis means you have to draw the arbitrary line which is parallel to x-axis, and see this arbitrary line first touches the y curve, that is blue color curve. Okay, so blue color curve equation is x squared is equal to 4y. So the x has to be taken from the curve x squared is equal to 4y. So then next this arbitrary line which is parallel to x-axis next touches the red color line, red color curve. So that is y squared is equal to 4x. So the next x has to be taken from y squared is equal to 4x. See now, in the place of x1 you are going to take x from this curve. So x squared is equal to 4y. From that x is equal to square root of 4y. In between you are having minus. So it is written. Next x2. That x has to be taken from this curve. So here x is equal to this 4. When you take it to the next side, it is y squared by 4 into dy. So what is square root of 4 is 2. And square root of y can be written as y power 1 by 2. And minus y squared by 4 into dy. So 2 is taken out, it's a constant. So y power 1 by 2. If you apply a y power n integration formula, it is y power n plus 1 divided by n plus 1. So half plus 1 is 3 by 2 divided by 3 by 2. Minus So 1 by 4 is a constant. So remaining is y squared. If you integrate, it is y cube by 3. So this 3 by 2 can be written as 2 by 3. So already or 2 is there. 2 2s are 4. 4 by 3 y power 3 by 2 minus y cube. 1 into y cube is y cube by 4 3s are 12. And the limits varies from 0 to 4. So 4 by 3 is written here. In the place of you have to apply the upper limit. So in the place of y, you have to substitute 4. It is 4 power 3 by 2. So 4 power 3 by 2 means it can be written as 4 root 4. So 4 power 1 and 4 power half. If you add, it is 4 power 3 by 2. So 4 power 3 by 2 can be written as 4 root 4 minus. So upper limit, if you apply, it is 4 cube by 12. So when you apply the lower limit, everything will be 0. So you will have only this. So if you simplify, what is root 4? It is 2. 2 into 4 is 8. 8 4s are 32. So 32 by 3 minus 4 cube is 64 by 12. So 64 by 12. So the LCM is 12. So therefore 32 into 4 is 128 minus 64. That is equal to 64 by 12. That is equal to 16 by 3. So therefore the area between the two curves. So that is A2. A2 is nothing but the area between the two curves. That also 16 by 3. Next we have to go to A3. So the green color part we have to find out. So you see, this A3 is the area bounded by blue color curve. You have to choose x-axis, x equal to 0 to x is equal to 4. If you choose y-axis means, you see that area bounded by this blue color curve, y-axis, y is equal to 0 to y equal to 4 means which will come? The purple color and the yellow color will come. So what is needed? You need the green color. So how to choose the axis? The area bounded by the blue color curve, x-axis, x equal to 0 to x equal to 4 means you will get the green color curve. So for finding A3, you have to choose the axis as x-axis. So here how many curves are involved? Only the blue color curve is involved in A3. So only one curve. So you have chosen x-axis. So the formula is y dx. So this area A3, how it is? It is lies above the x-axis. So therefore I have written y is positive. So this y has to be taken from the blue color curve. The blue color curve equation is x squared is equal to 4y. So from that you have to take y. So x squared is equal to 4y. What is y? X squared by 4. So in the place of y you have substituted x squared by 4. So 1 by 4 is taken out. So what is remaining? X squared. If you integrate x cube by 3. So this 3 is taken out means it is 1 by 12. If you apply the upper limit, it is 4 cube. So 4 cube is 64 and the lower limit is 0. So the answer is 64 by 12, that is 16 by 3. So therefore A1, A2, A3, everything is equal. It is equal to 16 by 3 square units. So therefore, so what is asked, the question is it possible to divide? If so, find the area to be divided among them. So we have to conclude, yes, it is possible to divide among them and the area is 16 by 3 square units. Thank you, students.